Uh, Today well, actually, in this video, I'll be explaining Caesar cipher. Some things you need to know before getting into this program is what a string, a character, a char, and how to use strings, how to use chars, and how to use command line input, or CLI, I guess you could abbreviate it as. So, whenever in C, we can store sentences using a string. So how we do this is we put it between double quotes. So we say, I am a collection of characters. And let's recurse into the definition of characters before continuing with the explanation. A character is just a single letter or symbol or anything basically on your keyboard that you can find. It is a singular version of it. So this is illegal, while this is not illegal. This is not illegal. It's just a single character, okay? And back to strings. Strings are a collection of characters. So if I select string of 0, that's this first item. That would return true when being compared to this. So the first element of string is a character, that is I. So now that you have a basic understanding of strings and characters, I'm going to go through command line input. And I'm going to actually do that by starting to write the program. So int main, int argc, string argv, which is an array. So whenever we're writing a program with command line input, we're thinking about how we're going to call it. So we're going to call it by calling Caesar, for example, and then putting, in this case, a integer in as a input. So whenever we create a command line, whenever we have command line input in our program, in our main function we put argument count and argument vector, which stands for argument array, really, into our parameters. So argument count returns the amount of arguments, including the call to your, I guess, program. So /Caesar is your first argument, so that's 1. And then 13 is your second argument. That's your argument count. And then your argument vector is just a list of all of your arguments. So in the first item in your argument list would be /Caesar. The second one would be 13. So the first thing we want to do in our program is, of course, check if we have the right amount of arguments. So if argc does not equal 2 as it should, so 1 for the actual call to our program and 2 for the integer we're trying to input, then we just want to return 1, which basically breaks the program and makes it not work. So we've checked that the user's put in the correct amount of arguments. Next, we want to create a string called plain. This is just our original string. So get string plain text int shift. So we actually want to have the integer that we pass in, which will shift each letter in our string. So CS50 does a good job of demonstrating this. So Caesar cipher, what it does, takes H and moves it 13 places to the right in the alphabet. E, 13 places to the right in the alphabet. L, 13 places to the right in the alphabet, etc., etc. We're passing in 13 and the string that will eventually be shifted, that each character in the string will be eventually shifted by 13. So yeah, so we want to get the integer that we're actually shifting with. So a2i, which is, I'm pretty sure, imported in standard lib, takes a string and converts it to a integer. So we want to take our integer and pass it into that function. Our integer being the second argument is at index 1. So now that we have our shift and our plain text, we want to printf cipher text, so that whenever we print the individual characters of our new string, they will go right after this. And then we want to loop through each character in our plain text. So string length of plain. We want to increment I plus 1. We want it to take string length amount of times to print each character. So in the case of a exclamation mark, comma, period, whatever, we just want to print it. We don't want to actually shift an exclamation mark. We don't know what that'll be. So there's a convenient function for this. So is alpha determines whether a character is a character of the alphabet or not, essentially. The technical definition is a bit different, but that's what it does in general. So if exclamation mark, don't think I've explained it, but basically it means not. So if it is not an alpha character, then we just want to print it out. We use %C for printing out characters. And we want to print out plain at our current index. Okay, so now that we have that done, so we know that if it's on alpha, it'll go through here and it'll print it out. But if it is an alpha, then we want to actually shift it and then print it out. But we actually have a formula for doing this. So the problem with just adding 13 to, or whatever shifting number to our letter, is that sometimes that'll go over I guess our limit. So okay, I'm explaining it terribly. Let me give you an example. So let's say Z, right? Z has an ASCII value of 90. So if we shift it by 10, we get a ASCII value of 100, which actually translates to lowercase c. So obviously in our program, we don't want that to happen. We want Z, if we add 10 to Z, we want us to go back to the beginning of the alphabet. So Z, here's Z, here's A, here's everything in between. So if we add 10 to Z, instead of moving 1 to the right and becoming 91 as a value, we want to go back to A, which is 65, uppercase A that is, and then go however many long until we've shifted 10 times. So to do that, what we're actually going to do is we're going to take Z, and we're going to take that number, which is 90, and subtract it from A, which is 65. So what'll that be? That'll be 25, 65, 5, 70, 20, yes. So 25. Okay, so let's think about that. So Z has a value of 25 characters from A, so that's useful to us. So we have Z minus A, the 25th character, and then we add our shift to it. So let's say our shift is 10. Now we have 35. So how do we put this as just 10 shifts from the beginning of A, right? Because this is what we're doing. 25 is Z, 25 characters away from A, right? And then we just want to shift 10. Since we are at Z, we go shift 1, we go to A, and then we shift 9 more times from A. We'll actually use a modulus, so 35. Then we do mod 26, since there's 26 total characters in the alphabet. And that'll give us 4 plus 5, 9. So if we shift Z1 to Z10, our first shift is back to A. So we have A, and then B, C, etc., until the 9th character. So this is our formula. We take Z minus A, which is the distance of our given character from our start of the alphabet, I guess, A, 25, but we'll just do that calculation all the time, z minus a, or whatever character minus a, and then we do modulus 26 and we get 9. But then 9 of course won't work as anything because 9, if uppercase A starts at 65, 9 will literally be some random character. So let's just add 9 back to lowercase a, and there we go. That's the ASCII value of our new character. So let's do that. So that only applies for uppercase or lowercase. Uppercase A starts at 65. Lowercase a starts at 97. So we will have to do different formulas for uppercase and lowercase because the offset will be different. So we take our character, we subtract it from a to find its offset from from the start of the alphabet, and then we add our shift to it. And then we do modulus 26. So reset it if it goes over 26, or over 25 rather. And then that will be how much we shift from A, and then we add that back to A to get our actual character. If it was a uppercase number, then we just do the same thing pretty much, except instead of subtracting lowercase a, we will subtract uppercase a, still add our shift, still do modulus 26, but then also add uppercase a. And so if you're wondering why this plane of I is greater than z, it signifies that a character is lowercase. Well, if we know that uppercase a starts at 65 and uppercase z is at 90, then we know that anything greater than 90 that is a character has to be a lowercase number, a lowercase character, since uppercase a starts at 97. So with this, we also need to print a line break. We don't want to be having our code look ugly. So with this, our program should be complete. So let's make Caesar. Looks like we had a hidden 3. Misspelled it. Oh, unidentified error M. Don't know why I put M for shift. I guess it's just some habits. I like to put random characters for my variable names. Still getting errors. Some live debugging right here. So right here it says included C type, or for is alpha. Okay, so include C type dot h. So is alpha the actual function? What is included in the C type dot h class? So that should remove some of our errors. So I didn't include that, so I couldn't use this method. And then it seems like I straight up just don't have a plus sign here. So let's try and make it again. And it seems to have compiled. Just remove some of the silly mistakes we made. And then let's do Caesar 13. Let's look at what this example gives us. Hello, URYYB. Hello, URYYB. So it looks like our program is working. Thank you for watching.